Hello, welcome to JEE company. Now we are looking into chemical equilibrium. So for a chemical reaction you will be having multiple items which is a reactant which produces the final product. From the product, if it is able to get the reactants back, then it's called chemical equilibrium. What will be chemical equilibrium? Chemical equilibrium is a state in which both the reactants and products are present in concentration which have no further tendency to change with time. That's called chemical equilibrium. I am trying to show, considering A is there plus B, you got AB. And if there is a slight modification of A extra, automatically there will be impact in the B. So that's referred to as chemical equilibrium. Let's talk about chemical equilibrium. So, chemical equilibrium relies and depends on the rate of forward reaction is equal to rate of reverse reaction. So, how much the rate of forward reaction from the reactants is happening is equal to the product which is created as the reverse reaction. You can see these are the two products. They reacted to get the final output as this one. So, in the initial stage, the reactants will be, the reaction with the reactants will be more, and afterwards the reaction from the product will be more. So this process is called dynamic process. At one stage, there won't be any reaction to here and there won't be any reaction to here. So this is a forward reaction. Your nitrogen and hydrogen forms ammonia, NH3. Whereas NH3 at one stage it's turned back to come out as nitrogen and hydrogen. At one stage both will be at a equilibrium stage. So in the initial stage, if this is lesser, automatically this guy will be sending lot of forward reaction will be happening. Once if it is more, reverse reaction will happen. So obviously the concentration of the reactants will be getting lower here. You can see it's coming down. And the concentration of the products, it's going up. At one stage the concentration is stable. That's equilibrium is established. This is referred to as chemical equilibrium. The time taken or time at which the equilibrium is happening, that's referred to as time of equilibrium or equilibrium time or equilibrium position. You can see the forward reaction is more now when compared to the reverse. Now the reverse reaction is more when compared to the forward. At one stage both are equal. So it's called equilibrium. It depends on the initial concentrations. Maybe because of the energies of reactants and products, how much energy it hold to form the product, or from how much energy it hold to come back as a reactants. And organization of reactants and products. So it rely on all the things for the equilibrium position. So it can be defined using an equilibrium constant. That equilibrium constant is directly proportional to the products and inversely proportional to the reactants. So the equilibrium constant is greater than 1 if the reaction favors products at equilibrium, whereas K less than 1 if it is rely on the reactants. So if it is less than 1, the reaction favors reactants at equilibrium. This is referred to as equilibrium constant. So this is my equilibrium equation. Over here your nitrogen hydrogen form NH3 and an equilibrium is formed, and the equilibrium constant is equal to product divided by reactants. That's, you got 2 NH3 here, so NH3 power 2, N2 power 1 and H2 power 3. This is referred to as equilibrium constants. Now I'll talk about dynamic equilibrium. Dynamic equilibrium is a chemical equilibrium between a forward reaction and a reverse reaction where the rate of the reaction is equal. That's referred to as dynamic equilibrium. So you can see here, at equilibrium the reaction does not stop. It is considered as equilibrium, dynamic equilibrium, and like every chemical reaction is reversible. You can see here, I got a fish tank, 10 fish. So if it is equal 5 fish, it is stable. This is referred to as dynamic equilibrium. So the reaction is going forward, and if there is any excess reaction, the reaction will go backward and it will become equal. That's referred to as dynamic equilibrium. The equilibrium relationship between the liquid and its vapor phase for a partially vaporized compound or mixture at specified conditions. That's referred to as liquid gas equilibrium. You can see, if this is a liquid, the pressure of the gas trying to escape from the liquid is happening from here, whereas the pressure of the atmosphere pushing on the liquid is here, and at one stage these two will be equal. That's called a liquid gas equilibrium, and it is expressed by the formula K is equal to X divided by Y, where K is the constant, that's equilibrium constant. X is the mole fraction of a key component in the vapor, and Y is the mole fraction of the same key component in the liquid.